So, hey everyone, welcome to another video in the series of computational geometry. And in this video, we'll learn about Andrew's monotone chain algorithm. So, what is this algorithm? This algorithm is used to find the convex hull of a given set of points. But that arises this question: what is a convex hull? So, imagine there are nails hammered on the walls like this, in this fashion. Now you take a rubber band and you stretch it across the points. There you cover all the nails like this. Now, this shape of the rubber band is the convex hull of these nails. So if you just replace these nails with points, and this rubber band acts as a boundary of those points. This boundary is actually the convex hull of those points. So now that's pretty clear what a convex hull is. Okay. So now, but why this algorithm? Well, there are plenty of algorithms to find out the convex hull of given set of points. There is Graham scan, there is quick hull, there is Jarvis Marsh. But this algorithm is the easiest to understand and implement, and that is why it is the most common used. So let's look at the data structures involved. So for these points, there is an array. Now this array contains the points sorted in increasing order of their x coordinates. So P1, then P2, P3, P4, so like that, in increasing order of their x coordinates. And if these x coordinates are equal for some points, then they're sorted according to their increasing y coordinates. Now, how do you do it? You go from P1 to P11. Okay, you build the lower hull first, and then you build the upper hull. So while building each of the hulls, what you do is you push the points that are part of the hull onto the stack. So your stack actually consists of all those points which are which are part of the hull. Okay, so that is how it is. Now the algorithm. The algorithm is pretty simple. See, now consider there are 2 points already on in the stack, P1, P2 in that order, and P3 is the point under consideration. Now, say you're uh, say you're walking from P1 to P2 and then P3. So if going from P1 to P2 to P3 involves a counterclockwise turn, then you push that point onto the stack. So you, in this case, you push P3 onto the stack. But if going from P1 to P2 to P3 involves a clockwise turn, so in that case, you remove the middle point or you just pop the stack. So your P2 is removed. And what does the hull become now? P1, P3. So let's assume that there was another point P0 before P1 in the stack. So the hull became now P0, P1, and P3. So you check again, you repeat that step. You check the last 3 points again. You check if P0 to P1 to P3 involves a counterclockwise turn. If it involves a counterclockwise turn, then yes, we push point P3 and we move on. But if it does not, then you just pop P1 again and you keep repeating the same steps for the last 3 points. So that is how the algorithm is. You traverse the array from left to right first to build the lower hull, and then you traverse it from right to left to build the upper hull. But use the same stack because the stack actually contains the hull, the complete hull. So let's begin with the example. So these are the points, and this is the array. So for the first point, we are at the first point P1. So we have nothing to do with it. We just directly push it. So P1 is pushed. Our next point P2, we push that too. Now there are 3 points, and now this involves checking for turn. So going from P1 to P2 to P3. Is that a counterclockwise turn? Yes, it is a counterclockwise. So what do? You push P3. It is a clockwise turn. You push P3 onto the stack. Now next point, P4. We are at P4. Okay. Check for the last 3 points again. P2 to P3 to P4. Now, is that turn a counterclockwise turn? No. It is a it is a clockwise turn. So if it is a clockwise turn, what do you do? For these 3 points, you delete the middle point or you just pop this stack. So the stack is popped because it's a counterclockwise turn. It's a clockwise turn. So now the hull becomes P1, P2, P4. But you check again. You don't stop at one step. You check for each deletion. You check after each deletion. So the last 3 points, P1, P2, P4. Now, is that a counterclockwise turn? Yes, it is a counterclockwise turn, and so that is why you push P4 out of the stack. Okay, next point, P5. Check the last 3 points again. P2, P4, P5. Okay, that is a clockwise turn. So what do? You pop P4, and now the hull becomes P1, P2, P5. You check again. Is this a counterclockwise turn? Yes. So you push P5 onto the stack. Next point, P6. A counterclockwise turn again. See, first 3 points, P2, P5, P6. So you push P6 again. The next point, P7. Now, is that a counterclockwise turn? P5, P6, P7? No, that's a clockwise turn. Okay. So uh, you pop the stack. P6 is removed. The hull becomes now P1, P2, P5, P7. Oh, but you check for these 3 points again. P2, P5, P7. Okay, so that's a counterclockwise turn. Okay, so you push P7. Next, P8. So you check the last 3 points. Okay, now that is a clockwise turn. Okay, so you pop P7. You pop P7. Now the hull becomes P2, P5, P8. Now, is that a clockwise turn? Yes, it is a clockwise turn. You see, going from P2 to P5, you have to take a slight right to go from P5 to P8. So if a right is involved, that means it's a clockwise turn. So it's a clockwise turn. That means you pop P5. So now the hull becomes P1, P2, P8. You check again. Is that a counterclockwise turn? Yes, P1 to P2 to P8 is a counterclockwise turn. So we push P8 finally. Now next point P9. Now is that a counterclockwise turn? No, that is definitely a very sharp clockwise turn. P2 to P8 to P9. So we pop P8 and the hull becomes P1, P2, P9. Now that is a counterclockwise turn and we keep P9. The next point P10. Again P2 to P9, P10. It's a counterclockwise turn. We keep P10. We push it out of the stack. The next point P11. Okay. Now is that a counterclockwise turn? No. But is that a clockwise turn? Neither. What is it? The points P9, P10, and P11 are collinear. So what do we do? So there are basically two implementations of this algorithm. So one says that you include P10, and the other says that you don't. See, in uh, in these implementations, the only difference is that the point P10 may be considered or may not be. Okay, but the boundary remains the same. See, no matter you take P10 or not, the boundary remains only from P9 to P11. Okay, P10 is just the point that is on the boundary. So that does not change, and that is why we are implementing our algorithm where we do not count for P10. So all we check is if the last 3 points make a counterclockwise turn, we include the point. Okay, if they do not, we pop the middle point. So that's what we are going to do here. Since it's not a counterclockwise turn, we pop P10. That's it. The hull becomes P1, P2, P9, P11. So the last 3 points P2, P9, P11. Is that a counterclockwise turn? Yes. So we push P11. So that is we have reached the end of the array. That is this was the rightmost point. So we have traveled from the leftmost to the rightmost point, and we have completed building the lower hull. Now similarly, you build the upper hull. You know what is going to happen now. You are going to traverse each of the points again, and you will check if it makes a counterclockwise turn. You push them onto the stack. If it is not, then you remove the middle point. Now, now one might question: do I have to traverse every point again? Now, see, uh, it is clear that P9 cannot be a part of the upper hull at all costs. So, do I have to go on checking P9 again? Because I know it is not going to be a part of the hull. The answer is yes. And the reason is the cost. See, to check if a point makes a counterclockwise turn is just it's a mathematical computation. It takes a big of one time. But rather, if you wanted to check if that point is already in the hull, you have to maintain a lookup table or a hash map, and you have to maintain it. You have to insert every time, and you have to look up for it every time. So that involves complexity. That involves the this involves rise in space and time complexity. So that is why we just iterate to every point, and we just think that makes a counterclockwise turn or does or not. If it does not make the counterclockwise turn, it will not be added in the hull at all. That's what we do. But we'll skip all the points here, and I will just show what the hull will be. You know, the next point will be P6. These will make a counterclockwise turn, P9, P11, P6. So P6 will be pushed onto onto the stack, and the next point will be P3, as you can guess, and then the next will be P1. So in this order, this will be your hull: P1, P2, P9, P11, P6, P3. See, we didn't include P10, okay? P10 was here and we didn't include it. So that is how you make a hull. Now, where do you think this is used? So you might have seen those videos also um, where those in OpenCV you might have seen that there's these gesture recognition apps. So, for example, you do like this, and it identifies how many fingers there are. So what it does is it traces an outline of these fingertips. So that is where this algorithm is used. So that's all from this video. Thank you for watching.